Okay, we're back to solving some more problems here. Notice that when I click on this practice problem here, I get this message about no exercise available again. So the way around that is to try the quiz first. And then, so what I'll do is I'll press the quiz me. I really don't have to do the quiz. I just have to submit it. And this will open up the practice problems. So I really don't care what's in this quiz unless I know it. If I know it, then I'll try to do it and get my MP credits. But if I don't know it, then I'm just going into practice problems. And I'll go back to my study plan now. And I should be able to get into this exercise now. So here it is. Okay. Now let's solve this problem. So here you're trying to add these two terms together. They are like terms. It's 12x squared plus 14x squared. So we have a 12x squared plus a 14x squared. Since the x squareds match, that's the variable part of these two terms. They both have x squared, so they're identical. All we have to do is add the 12 and the 14, which makes 26. And keep those x squareds as they are, as an x squared. That would be our answer. Now, notice we did not add these exponents. Okay? Did not add them. We kept the x squared as an x squared. That's the end of the problem. Okay. Let's see what else is here. Okay, here's another one. 17x squared minus 7x squared minus y. 17x squared minus 7x squared minus y. Okay, first thing we notice is that we have some unlike terms here. The x squared doesn't match the y. But we could combine these two, 17x squared and a minus 7x squared. That makes 10x squared. And then you still have that minus y, so we drag it down, and that is our final answer. We stop. Because you can't add unlike terms like these two. X squared does not match a y to the first. So that one is finished. That's all we can do with it. Okay, here's another one. 5x minus 9x plus 7x. 5x minus 9x plus 7x. Now here we have all like terms. Three terms. All we have to do is add 5 minus a 9. That's a negative 4. Plus a 7 is a positive 3x. So that's our final answer. Okay. Now let's see what else is here. Let's see if there's anything else in here that we need. Well, here's some decimals, which you might have to use your calculator on, but notice we have a couple like terms. These y squareds can go together, and then we have a couple constant terms. They can go together. But our final answer, we'll have a y squared term and then a constant term, which will not be able to connect. We'll not be able to put those together. So this one, we could just do it right in here. We're going to end up with, see if you can predict this, minus 0.5 y squared. Okay, that's the 0.8 minus 1.3. And then it looks like plus 9.2 minus 1.1 is 8.1. Okay, and we'll try to submit that. Let's see. check my answer there. And it accepts it, it likes it. Okay, so we'll close that up. And come back in here and look for something else. Now, I'm going to go a little bit backwards here. And we're going to look at some of these questions. And remember, I'm just going in here to submit this quiz, but I can practice and I can do a little explanation here too. This is going to open up the homework. Anyway, I have a PQ raised to the 9th power. So back in here, PQ raised to the 9th power. Now, the shortcut method property tells us all we have to do is think of this as P to the first and Q to the first. And we will multiply 9 times 1 and 9 times 1. This will give us a P to the 9 with a Q to the 9. Okay, that's our shortcut. And that's what we use, the shortcut exponent rule. So you're raising a product to a power, so each of the factors in the product gets raised to that same power. Raising a power, raising a factor to a power means you just multiply the exponents of those powers. So this is actually power to power. Okay, power to power means you're multiplying the powers. So this is all we can do now. We leave it like this: P to the 9th, Q to the 9th, and it's understood this is multiplication. So that's our final answer for that one. Okay, let's go back in here and see what else is here. We might as well put this in here. Q raised to the 9th. Okay, now we move on to the next question. There we go. Okay, now this is y to the 3rd, z to the 5th, all raised to the 6th. So, okay. So we have y to the 3rd, z to the 3rd, all raised to the 5th. That's what it said, right? Now, y to the 3rd, z to the 5th, raised to the 6th. I got it backwards. So let me fix this in here. Okay, so that should be 5, and this is a 6. Okay, so here you're going to take this 6 times the 3 makes y to the 18th, and 6 times 5 makes z to the 30th, and that's where you stop. Okay. Let's see what else is in here. I'll submit this. That's fine. I just want to open up the homework questions for this section. So, okay. Let's try that again. That's the wrong one. Okay. Let's do this one here. a little slow. Okay, so here's something. Alright, we did one like that. Let's try something else here. I want to see a quotient rule. Okay. Here we go. Okay, this is pretty messy. MP over n to the 13th power. So let's get rid of some of this stuff here. Okay, so what's the problem? Yeah, MP over n to the 13th. So everything in the numerator and everything in the denominator has to be raised to the 13th. So you have an m to the 13th, p to the 13th, and an n to the 13th. And there's nothing else you can do. Done. Now, let's say you had a problem like this. Let me just say we have an a squared b cubed over a, let's say we have a c to the 4th, and all of that is raised to the 4th power. Okay, the first step would be start inside, simplify what you can inside. We can simplify this a squared over a by making it a to the 1st power. Okay, now the other factors in there cannot change. Okay. So all I did was change that a squared over a to just an a in the numerator. I'm subtracting these exponents. 2 minus 1 is a 1, and my result stays in the numerator when I use this rule of subtraction. 2 minus 1, and I leave my result in the numerator, regardless of the number that's left in this exponent here. Leave it in the numerator. Now I deal with this 4 out here, and I raise everything to the 4th. So I have a to the 1 times 4 is 4. B cubed to the 4th is b to the 12th. And c to the 4th raised to the 4th is c to the 16th. So the key is in remembering when to add these exponents, when to multiply them, when to subtract them. And of course, when you're adding and subtracting like terms, you don't do anything to the exponents. So you have to remember all the differences. Okay, so that should get you through a few exercises. And let's see.